10 vibrations every 4 seconds allows us to get the frequency. It'll be 10 over 4. So it would be 2.5 vibrations per second, or we call those hertz. And then we are given the distance of 5 meters over a time of 4.5 seconds. And we are asked to determine the wavelength. So this is about the speed of a wave, with the speed being able to be determined in 2 different ways. The first way is using the distance and time. So speed is distance divided by time. Secondly, speed is also equal to lambda f. So these two can be combined together. They can be set equal to each other. And then we can rearrange for lambda by dividing both sides by f. So it's okay if you decide to just calculate out the speed first, get a value, and then plug that value into the second equation. But with this method, you kind of just simplify down to your final equation and can substitute from this point on. So it'd be 5 meters. And in the denominator, we have 4.5 seconds times the frequency of 2.5 hertz. Get the calculator out. And that is giving me 0.44. The SI units for wavelength would be meters.